Okay, so now we're going to move on to inverses of functions. Okay, and so here is the notation that we use. We do this f. If the function is f of x, then what we do is we put sort of an exponent of -1 on the f. Here, I'll make it a little larger here. We just do f to the -1 power, but we don't say f to the -1 power. We say f inverse. Okay. And so if f of x is a function, we say f inverse of x as f inverse of x. So we don't say f to the -1 power, we say f inverse. Well, what is f inverse? Well, it really is a very simple concept, okay? If we have a function f of x, and if f of x contains the point 7, 5, then f inverse of x contains the point 5, 7. See, all we really did was we took the x value and we made it a y value. So now the y is 7. And we took the y value of 5 and made it an x value, 5, 7. Okay? And so all we do is just swap the x and the y value to get the inverse. And here's another example. So if we know that f of 3 is equal to 17, then f inverse of 17 is going to be equal to 3. We take the y value and we put it inside as the x value. We take the x value and we take it outside as the y value. Okay? So basically the output becomes the input and the input becomes the output. Okay? Let's look at another example graphically. Okay, here you can see there is this graph right here, and you can see this graph is right here. These two graphs are inverses. So if this is the graph of f of x, then this is the graph of f inverse of x. And you can see that they pass through inverse points. You can see that f of x passes through the point 1, 5, and f inverse of x passes through the point 5, 1. F of x passes through the point 0, 3, and f inverse passes through the point 3, 0. Lastly, f of x passes through the point -1, 2, and if we swap these two, we get 2, -1, and f inverse passes through there. And one of the ways that we can understand an inverse is that it passes through, is that the inverse is reflected across the line y equals x. This line y equals x acts as a reflection of f of x here to f inverse of x here. Okay, so let's say we have this function f of x, and let's say it's a linear function 2x minus 5, which, by the way, is a one-to-one function. It is important in order to identify the inverse of a function. In order for the inverse of a function to be a function itself, it has to be a one-to-one function. Okay? And 2x minus 5 is one-to-one because all linear functions are one-to-one. So I'm going to make a table of values here, and my x values I'm going to do -2, -1, 0, 1, and 2. And when I plug each one of these into 2x minus 5, if I plug in -2, 2 times -2 is -4, -4 minus 5 is -9. If I plug -1 in, 2 times -1 is -2, -2 minus 5 is -7. Plug a 0 in, 2 times 0 is 0, minus 5 is -5. If I plug in a 1, I get -3, and if I plug in a 2, I get -1. Okay? But now what I want to do is I want to make a similar table of values for f inverse of x. And so since we understand that f inverse is making all of the y values x values, what we're going to do is we're going to now move these y values over into the x column. So suppose x is -9 or -7 or -5 or -3 or -1. Okay? So now if I plug -9 into f inverse of x, I should get -2 as an answer, as a y value. If I plug -7 into f inverse of x, I should get -1 as an answer. If I plug in -5, I should get 0. If I plug in negative 3, I should get 1. And if I plug in negative 1, I should get 2. And so now I'm going to show you that this is indeed the case by transforming 2x minus 5 into its inverse. So here's the procedure. The first thing I'm going to do is I'm going to write out y equals 2x minus 5. So I'm going to change the f of x into a y. The next thing I'm going to do is I'm going to turn all the y's into x's and all the x's into y's. So I'm now going to have x is equal to 2y minus 5. Okay? Now I want to be clear here. All I did was instead of writing a y, I wrote an x. And instead of writing an x, I wrote a y. Okay? So I wrote x equals 2y minus 5. And because I turned all the y's into x's and I turned all the x's into y's, this is f of x and this is now f inverse. But I need it in terms of y. And so what I now need to do is I need to solve for y. So now I'm going to solve for y. So I want to get y by itself. So I'm going to add 5 here, and I'm going to add 5 here. Okay, and I wind up with x plus 5 equals, this is going to cancel, equals 2y. And now I'm going to divide by 2 on both sides, and this cancels, and now I have it. I have y is equal to x plus 5 over 2. Okay? Now let's find out if this is indeed working. So if I plug in negative 9 for x, if I put a negative 9 here, negative 9, let's go ahead and do this over here, negative 9 plus 5 over 2, well, negative 9 plus 5, that's negative 4 over 2, which is negative 2, and sure enough, we get negative 2. If I were to put negative 7 in, negative 7 plus 5 is negative 2. Negative 2 divided by 2 is negative 1. Negative 5 plus 5 is 0. 0 divided by 2 is 0. Negative 3 plus 5, that's 2. 2 divided by 2 is 1. And then negative 1. Negative 1 plus 5 is 4, divided by 2 is 2. And so we can see truly that this works. That if we identify the inverse, that it will swap all the x's and the y's. Okay? Now, the last thing I want to say here is that we should transform this. We can transform this into a linear function by changing it to y equals x over 2 plus 5 over 2. Now, and if we go even one step further, we can do it as 1/2 x plus 5 over 2. And now we can see that it's in mx plus b form. Okay? And so what we're going to do in the next video is we're going to do a bunch of examples where we take functions, different kinds of functions, and we transform them just like this into f inverse of x.